All right, welcome to E-Period Algebra 1. You've made it to the finish line. It's the final day. It is Thursday, May 21st. All right, so let me go over some housekeeping chores. All right. The 6-3 quiz. I need Mr. Campbell and Mr. Hughes to stay on classroom after we end today so we can chat a bit. Mr. Gilmartin, I don't have a 6-3 quiz from you. Mr. Martin, did you submit a 6-3 quiz? Or is that my stack to grade?
It's it's when I turn it in, it says like it's not able to like turn it in.
What do you mean?
Like file, it says like file can't be turned in for some reason.
Is that via Blackbot or via email?
Blackboard. I could try to.
Yeah, I don't know. Maybe there's a deadline on there that's already passed. So email me a copy.
All right.
Okay. This is let's see. I say 6-3. This is the 6-2 quiz. All right. So Campbell, I need to see you after class, and Mr. Hughes, Mr. Clark. I don't believe I've got a 6-2 quiz from you. Did you get someone in? Or do you have one sitting there that you can email me that you took and just for one reason or another I didn't get?
No, sir.
You didn't take it?
I did. It's just not here. It's at my mom's house.
Because today's the last day I can take any work. Is there any way you can get it to me today?
I can try.
Another option is you can email me and I can email you a copy back. Just submit your request. I need a copy of the 6-2 quiz. I can send it to you that way. You can take it, and again, today they said today's the last day I can take any late work. Okay.
Got it.
Email me a copy if you want to go that route. Okay.
Mr. Gaffney.
All right. Let me go. No, I'm not taking questions. Let me go through my list. Let's see. The party. Martin, did you mail me the 6-2 quiz?
Is it the 6-3 quiz or the 6-2 quiz?
6-2, the one from about a week ago. It was given last Tuesday, the 12th. Just make sure I've got it. Okay.
Yes, sir.
Here
it is, sir.
All right. Why don't you email me after class? Email me a copy because I don't know that I'm not showing it. I have a copy of it. Okay.
Okay.
Today's the last day for late work. Okay. Let's see. If anybody talks to Mr. Seeley and Mr. Seeley, I need his too. He's kind of dropped off the map. All right, the 6-3 quiz, which was given out on Tuesday, that was due before the start of class today, unless you submitted in the last 15 minutes. I don't have a 6-3 quiz from Mr. Campbell, Mr. Davidson, Mr. Gilmartin, let's see, he's not even here, and Mr. Seeley, if anybody sees him. Everybody else, I've got your 6-3 quiz. Okay. The switch has already been turned on to drop the lowest quiz grade, so you don't want 2 zeros. I mean,
Mr. Gaffney, the names that you just called, those were the people that didn't take the quiz?
All right, if you wouldn't talk over me, you'd hear it. The names I called are the people I do not have quizzes from.
Okay.
All right. If you want, let's see here. Let me just look over my notes and the other missing work. If you want, if you've got missing classwork or homework problem sets that you want to submit, I would need them today. Okay? Today is the last day. So if you want to go back into Blackboard, see if you're missing anything. It should be attached with that date. Copy of it. You can submit it, but as I would have. Mr. Hughes, can you mute the video game you're playing or mute your speaker, whatever you're doing? I would need it by today. Or if you see you need it and you can't for whatever reason can't download a copy of it, send me an email today and I will send it to you, but I would need it by the end of the day. Okay?
Mr. Gaffney,
Yes, sir.
I'm emailing you both the 6-2 quiz and the 6-3 quiz, just to be safe.
I've already got your 6-3 quiz, so don't send me another one.
Okay.
I've already got your 6-3. That's why
Yes, sir.
you called. Mr. Velasquez, on the 6-2 quiz, if you didn't grasp the material, so if you want to get on today with the office hours 2 to 2:30, maybe we can repair some of the damages, but we missed the boat severely on that one. Okay, not sure exactly why, but if you want to take a second bite of the apple, come on during office hours today, 2 to 2:30, and see if we can mitigate some of the damages. Okay. So let's see, Mr. Kelly, came on late. Let me see if I've got anything for you. Missing anything? Okay, doesn't look like it. Okay, any questions for me? Any questions for me? None? All right. Well, we're going to kind of pick up where we left off on Tuesday. It's the last section, of course, we're doing. It's section 6.4. I believe I loaded it on Tuesday's date there, a copy of 6.4 problem set 1. And it's 6.4 problem set 1 is kind of the advanced version of 6.1, 6.2, 6.3, where we're solving systems of equations by eliminating variables. One we did by addition, one we did by subtraction, one we 6.1 we did with graphing, so we knew visually. And this is kind of the culmination where we're going to use multiplication and division, meaning that I've got a situation where I've got both pairs of variables do not have identical coefficients. I'm going to have to multiply one or both equations by a value, both equations with identical coefficients, so I can attack one of them and eliminate it to solve the remaining variable. So I'm going to kind of harp on that because if you probably don't recall, but PSATs, SATs, which of course you haven't taken, they love systems of equations. And in a 50 question test or so, you could easily have 3 or 4 of these. So I want you to be good at it. So we get those mastered. They're not hard. You just need to know how to do them. All right, so that's kind of the plan. What I'd like to do is looking at Khan Academy. He's got, if you ever get stuck or you're looking at this over the summer or doing some kind of summer school algebra kind of buffer or refresher, Khan's got probably anywhere from 12 to 15 videos on systems of equations. So to start the day, I'm going to run over one of them. Where he's going to solve. It's a pair of equations that don't have identical coefficients that attack that x or that y that has identical coefficients. So we're going to have to multiply one or both those equations to get identical coefficients to eliminate that first variable to solve for the remaining variable. So we're going to watch a Khan video. And then we're going to go back to 6.4 problem set 1. You got some loose leaf paper handy. We did 1 through 3 on Tuesday, and then we're going to do kind of collectively. I'm going to challenge you a little bit, do a little kind of Jeopardy type solving on some of the problems on the back page. All right. Questions before I turn the video on? Okay, so let's see if I can pull this up. This over here. All right, so here we go.
we have this system of equations here. 3t plus 4g is equal to 6. And we have negative 6t plus g is also equal to 6. And there's a bunch of ways you can solve systems of equations. You can graph them. You can solve by substitution. But whenever you see the coefficients on one of the terms, in this case the t term, and they're almost cancelable. And when I say cancelable, if I add 3t to negative 6t, you won't be able to cancel them out. The t won't disappear. But if I were to scale the 3 up, if I were to multiply it by 2 and it becomes 6t, and then I were to add these two things, then they would cancel out and I would be left just with g's. So let's try to do that. Now remember, I can't just multiply this 3t by 2. In order for this equation to hold true, anything I do to the left-hand side, I have to do to the right-hand side as well. And I have to do to the entire left-hand side. So let me multiply this equation by 2. So I'm multiplying it by 2. So let me just write it here. So I'm going to multiply 2 times 3t plus 4g is equal to 2 times 6. Anything I do to one side, I have to do to the other side. The equality still holds true. So 2 times 3t is 6t plus 2 times 4g is 8g is equal to 2 times 6, which is 12. So I really just rewrote the same information, the same constraint in this first equation. I just multiplied both sides by 2. Now, let me write the second equation right below, and I'll write it in orange. So the second equation right here is negative 6t plus g is equal to 6. Now, think about what happens if I were to add these two equations. And remember, I can do that because I'm essentially adding the same thing to both sides of this top equation. Or you could say I'm adding the same thing to both sides of this bottom equation because the other equation is inequality. This negative 6t plus g, it is 6. So if I'm adding 6 to 12, I'm really adding the same quantity to the left-hand side. That's why I can do it. So let's add the left-hand sides together. When we do that, these 6t's cancel out. That was the whole point behind multiplying this first character by 2, so that the 3t becomes the 6t. And we're left with 8g plus g is 9g is equal to 12 plus 6, which is 18. Divide both sides by 9, and you are left with g is equal to 18 over 9, or 2. So we've solved for g. Now we can substitute back and solve for t. And we can use either of these equations. Let's use the second equation right here. So we have negative 6t plus g. We just solved for g. G is 2 is equal to 6. And we can subtract 2 from both sides of this equation. Subtracting 2. The left-hand side of the equation, that cancels out. You have negative 6t is equal to 6 minus 2 is 4. Now I can divide both sides of this equation by negative 6. Negative 6. And we're left with t is equal to, what is this? T is equal to negative 2/3. And we're done. We've solved for a t and a g that satisfy both equations. We just saw that it satisfies the bottom one. If you want to feel good that it satisfies the top, substitute them back into the top. 3 times, let's do that, 3 times the t we got, negative 2/3, plus 4 times the g we got, so plus 4 times 2. Let's see what that is. 3 times negative 2/3, that's negative 2. The 3's cancel out. Plus 4 times 2 is 8. Negative 2 plus 8 is equal to 6. And that's exactly what that first equation got us. So these two values definitely satisfy both equations.
All right. All right. So that was kind of a good overview. If you got pencil and paper handy, or if you printed out 6-4 problem set 1 that we were working on Tuesday, we're going to pick up on the side 2 of that. So let me pull that up. Let's see, that should be it. Okay. And we actually did 1 through 3 on Tuesday. Let me blow up the version.
I have a question. Are we just like practicing, or is this going to be due?
We are practicing.
Okay.
Okay. All right. So I'm going to skip number 4. I'm going to come back to that because that's got some challenges with it. So let's, if you got a piece of paper, jot down question 5 on a piece of paper, unless you printed this out. I'm gonna give you a minute to write it down. Let's walk through it collectively and figure out a way we can solve this. Okay, now once you've got it written down, we've got to eliminate either the x's or the y's. All right, doesn't matter. We got options here. We got choices. All right, but as you can see, the x's, the coefficients are 4 and 2. The y's are -3 and -1. So by adding or subtracting these two equations, I don't eliminate anything. So I don't move the needle at all. So I've got to pick one. All right. So if I wanted to eliminate the x's, I would multiply the bottom equation times 2, right? And then I'd have 4x and 4x. All right. And I could actually multiply it times a -2 if I wanted to, or a +2. If I multiply it times a -2, then I would add the two equations, but because I'd have a +4x and a -4x. And if I add those two, the x's would disappear. So that's two options right there. Multiply the bottom by -2 or a +2. Or we could go after the 3's. And again, I could multiply that bottom equation by 3. I'd have to subtract the bottom equation from the top for the y's to go away. Or I could actually multiply that bottom equation times a -3, which would give me a +3y. So I'd have a -3y and a +3y. And I would add the two equations for the y's to disappear, and then I'd have the x's to solve for. So you got 4 options there. Someone tell me, pick one of those 4 options, and let's do that option. Doesn't matter to me. Anybody? What's that mean, Mr. Martin?
X's.
Okay, we're gonna go after the x's, all right? So we're gonna multiply the bottom equation times 2, okay? So, so let's do something here. So do we want to add the equation for the x's to disappear, or do we want to subtract? Because if we add, we want the x's to have the same coefficient with opposite signs. If we like subtracting better, we'd keep the same signs. So we'd multiply times a +2. Preference? All right, I'll pick one in. All right, so I like to add to eliminate things. So I'm going to multiply this bottom equation by a -2. So if I multiply 2x minus y equals 10 by -2, I would have -4x plus 2y equals 20, right? So let's do some here. All right. So I'm going to line through this guy because I just multiply that bottom one by 2. I got a +4x and a -4x. So I'm going to have to add these two for the x's to disappear. So 4x plus a -4x is 0, which is what we wanted, right? And I got a -3y plus 2y equals -y, right? And I've got 22 plus 20 is what, 42? But we're solving for y, not -y. So if I multiply both sides of that equation by a -1, I get y equals a -42. Does that make sense? Anybody lost?
It makes sense.
All right. Let me just double check something here. Did we do that right? 4x plus 2y. Oh, we did. There's an error there, right? Anybody catch it? Evidently not. I thought that number seemed unusually large. What did we mess up? All right. We multiplied that second equation by a -2, right? So this actually should be, should it actually be a -20, right? It should be a -20, not a +20. So So let's do that again. The 4x's added together disappear. The negative 3y plus 2y is negative y. And 22 plus a negative 20 equals a positive 2. That makes this a little more reason. I thought the number is large. So y equals 2, right? Everybody good so far? All right, so now we're just going to plug that 2 back into either equation. Makes no difference which one. I would look at them. Sometimes one is the math's easier or simpler than the other. And I am going to plug in, let's see, I'm going to plug it into the top equation just for the heck of it. It doesn't matter. So we end up with 4x minus 3 times 2 is a minus 6, right? So we got 4x minus 6, combining steps just a little bit, equals 22, right? So if we add 6 to both sides, we end up with what? 4x, backspace, 4x equals, if we add 6 to both sides, we get 28, right? If we divide both sides by 7, we get x equals 7. Oops. There's another error there, right? What did we do wrong? Let's go back and backtrack. Y is actually equal to what?
Negative 2.
Negative 2. So this actually would be a positive 6, right? So then we're going to subtract 6 from both sides. That was a trick to see if you were paying attention. So we're going to subtract 6 from both sides. So we end up with 4x equals what? 16? All right. 22 minus 6 is 16. And we get x equals 4, right? So our ordered pair where these two lines intersect is 4 and negative 2. Agree? Agree? Anybody lost in the sauce?
Yes, sir.
You're lost in the sauce?
A little piece of oregano.
All right. Let me, let's do something here then. Let's see if we can unravel some of the confusion. All right, let's look at number 6. Jot that problem down. I'll let you jot it down. Let's see if we can do it without the multitude of errors that I committed there. Okay, so let's talk about it collectively, then I'm going to have you solve it, okay? Let's see. If I went after, I'm going to have to either eliminate the y's or the x's, all right? If I eliminate the y's, I'm going to have to multiply the first equation by 3 and the second equation by 4, right? So I got to multiply both equations by a value, which is almost kind of just doubled my work. If I went after the x's, all I have to do is multiply that second equation by either a positive 3 or negative 3. So by going after the x's, you just reduced your workload significantly. So there's more than one ways to solve these. Some involve more work than the others. And if you're like me, I like to be lazy. I want to do the least amount of work possible, but still get the right answer. Also, the problem is if we do the step, if we take the route that involves more work, you've just increased the odds or likelihood of you having making a careless error. So if we have less work, less likelihood of careless errors. All right. So I want you to start this problem, and I want you to start with multiplying the second equation by 3. Okay, so multiply the second equation by 3. I'm going to give you a minute to do that. Multiply the second equation by 3, all the way down the line. Both sides, everything on both sides of the equation, because I can do anything I want. All right, that's the properties of equality of equations. I can do anything I want to both sides of the equation as long as I do it consistently and throughout the whole thing. So do that first.
Done.
Okay, give me a minute to catch up. All right. So did everybody get 3x plus 9y equals negative 30? All right. So we're not going to use this guy anymore. Or not anymore. We're not going to use this guy. Okay. So I've got two positive 3x's. So what do I have to do to eliminate those x's? What method? What?
Subtract.
Subtract. Exactly. All right. Let me erase that. Okay, that's all right. All right, so let me catch up with it. It wasn't supposed to be erased. Let's do that. Let me,
3x plus 9y equals negative 30.
now we're back. Now we're back to square one. All right.
Minus.
All right. So I think it was Mr. Martin said we got to subtract the two equations, right? So do that. I'm not going to do it for you. You do it, and then I'll give you 30 seconds, and we'll talk about what we got left. Okay, what you should have had is a 3x minus 3x. The x's zero out or cancel out, which is how we designed it for that to happen. And then I've got negative 4y minus 9y. So now I've got negative 13y, right? I got negative, right?
That's what I got.
And I got
Negative 13.
4. Is that a positive 30 or negative 30?
It's negative on my.
Negative 4 minus a negative 30 is what? It's the same as
Negative 34?
No, come on. Negative 4 minus a negative 30 is the same as negative 4 plus 30, right?
Yes, sir. That's always how I mess up. It's always the signs that get me.
Double negative, just if you can just drill into your head, double negatives always equate to a positive. Double or consecutive negatives, double negatives always a positive. It's like negative 2 times negative 3 is a positive 6. All right. So next thing we got to do is what? Anybody?
Oh, divide each side by negative 13.
There you go. Divide each side by negative 13. So we end up with y equals what?
Y equals negative 2.
There you go. All right. So there you go. So now we just get our last and final step is we have to plug in negative 2 for the y on either equation. I'm going to pick the second equation just because I've got an x there with a coefficient of 1. All right. So now I've got x plus what? Actually, x minus 6 equals negative 10, right? And then if I add 6 to both sides, I get x equals negative 4. Is that what you got? Everybody get that? Okay. All right. Any questions on that before we move on? All right. Now, so let's look at number 7. Jot that down on a piece of paper. Let's look at number 7. Jot the problem, unless you've printed out the problem set. Okay. Again, we've got to eliminate one of the variables, leaving one to solve for. All right. If you go after one of the variables, it's a very complex process. If you go after one of the other variable, it's much less complex. which variable is the easiest to go after in number 7? Anybody?
Wise,
Why do you say that, Mr. Martin?
because one of the Y's is just like one Y, like
Yeah, it doesn't, it's got a coefficient.
smaller numbers. It's easier to.
Okay, so what are you going to do? What are you going to do to which equation to go after the Y's? Answer is correct so far.
I'm gonna subtract both of them.
Subtract of what?
Subtract the equations from each other.
If I subtract the two equations from each other, I'm going to end up with a negative x minus 3y equals 1. I have to do something before I start adding and subtracting the two equations.
Multiply something.
Okay, what? What are we going to do? Got to be more specific.
Multiply each problem.
We're trying to make this. We're trying to make this easy on ourselves. Let's do this. All right. If I multiply this first equation times 2, I'm going to have two equations. Well, I'm going to have two equations. I'm going to have a negative 2y equation and a positive 2y equation. That is the absolute easiest way to solve this. If I have to go after the, if I'm going to go after the x's, I got to multiply the first equation by 5, the second equation by 4. So I've got 220x's to eliminate, where you just have doubled your workload. So the easiest route is to go after that first equation and go after the y's. So you would end up with 8x minus 2y equals 18. Right? Now, I've got a negative 2y and a positive 2y. What mathematical process, what arithmetic am I going to do to eliminate those y's?
Subtract.
Subtract. So,
Add.
come on, Mr. Martin. 2y minus a negative 2y is a positive 4y, and I've still got the y's. I didn't eliminate diddly squat. So what mathematical process am I going to use? I guess that means add. So you add them, tell me what you get.
Oh, sir.
Mr. Clark, Mr. Hughes, Mr. Hunter, you're all still there, right? Mr. Kelly, you're doing the work. Mr.
Yes,
Gar,
sir.
Chris. So I'm not just talking to Mr. John, just me and Mr. Martin. All right, so Mr. Kelly, Mr. Martin said I'm going to have to add these two. So what do we end up with? What am I going to end up if I add these two?
Third. Oh. Can I say the answer?
No, not unless your name is Kelly.
It's not, sir.
Mr. Kelly, if you're talking, you have to unmute. I guess Mr. Kelly's not even listening to me. Mr. Kelly, are you there? Give me a thumbs up if you're listening. Somebody wants to text Mr. Kelly. I guess he's working on something else, definitely not algebra. How about Mr. Campbell? What'd you come up with?
For number 7,
Yes.
3x minus y equals 10.
No, he's not listening either. All right, Chris, how about you? Tell me what the answer is.
I haven't gotten it yet. I'm still working on it.
All right, Mr. Clark, can you help us out?
With this equation,
Yes, sir. I mean, come on, guys. If you're doing other stuff, I mean, Mr. Kelly's not even answering anything. Mr. Hughes is playing with his dog. You know, if none of you are going to pay any attention, I'm just going to end the class now, give you guys zeros for the day, and we'll move on.
This is the last day.
I already know this stuff. So I don't need to
Sir, this is the last day. What do you mean?
Wait, tell me, wait. What we got to do?
I'm asking basic questions on how to solve these problems, and none of you are getting anything right.
I didn't hear you at all. My headset cut up, disconnected from the laptop. And it was
Oh,
just
I'm
like,
sorry. I'll bring you over a new set of headsets.
You can give me something.
No.
That'll be like,
Oh my goodness. Oh my goodness.
Mr. Gaffney.
Mr. Hunter.
Wait, what were we going over again?
Oh my
Mr.
God,
Hunter, why don't you
He's
just
not
jump off
paying
the class?
attention on time.
I know it's the
you're
last
like-
day and all, but
Shut up, Graham.
You're like Mr. Hughes's dog.
Can I answer the
You're watching
equation?
television. You know something's going on. You just don't know what. This is absolutely ridiculous.
turned my quiz in on time.
Josh, you're
Yeah, I'm not paying
I
attention.
still have to answer the equation.
Mr. Gaffney, I did it on my the quiz on time.
Hell yeah.
yeah.
Shouldn't we get rid of the Y's?
Yeah, I think we're beyond that point.
I got the answer, sir.
All right, if I add the two equations, give me the equations that remains when I add those two equations.
13x plus 4y equals 26.
Oh, come on, that's absolutely pathetic. 13x equals 26.
Oh yeah, that.
Mr. Martin, you gotta get, this is gonna hose you for the rest of your life if we can't come up with the idea of +2 minus 2 is 0, not +2 minus 2 is 4.
I'm sorry, sir.
Well, I mean, you've got to get that basic down. Otherwise, you're going to miss every problem if we can't understand basic addition and subtraction. We end up with x equals 2. I'm going to cut this class real short, and because none of you all are paying attention. I'm just wasting my time.
Mr. Gaffney, you're not trying to learn
The
here.
last day.
Shut up, Graham. You get on my nerves.
It's the last day, and you guys aren't doing anything, right? You should be finishing strong instead of just sitting there doing.
Sir, you said this is practice. That's why I'm getting confused.
Yeah, Mr. Hughes, you should know better than anything. Just like in sports, right? If you
My
well, if you
headset cutting out, but I didn't hear
practice is to
you.
prep you for a game. If you screw around and practice, you're not prepared for the game. Come on.
That having a quicker test coming up because
I'm going to plug the 2 into either equation. I'm going to use the second equation since none of you are all paying attention anyway. So now I've got 10 plus 2y equals 8. And if I subtract 10 from both sides, I get 2y equals -8. Excuse me, equals a -2. And if I divide both sides by 2, I get y equals -1. Here's my ordered pair. My ordered pair is 2, -1. And if I do like Mr. Khan did and plug in those values into either one of those two equations, if I plug it in the first equation, that's going to be, let's just do that. If I go up here and plug in 2, that first equation, I get 8. Let's see, 8 minus a -1, so I get 8, which is a +1, equals 9, which it does. And the same thing would be true if I plug it into the bottom equation. The left side of the equation would equal 8. All right. I'm not going to do any more problems because the vast majority of you guys aren't paying attention. So I'm wasting my time and effort, and I got better things to do. So here's the deal. It's been nice having you in class this year. Hopefully you'll do some algebra over the summer so that when you come back next year and have Ms. Bobolski for geometry, you're all fired up and good to go. Mr. Velasquez, if you want help on that previous quiz, check in with me on office hours today. Mr. Campbell, Mr. Hughes, stay on after everybody else signs off. Mr. Gil Martin, again, I don't a 6-2 or 6-3 quiz for you, so you need to get it to me in one way, shape, or form. And that's all I've got. Any questions for me?
Mr. Gaffney, are you having your office hours today?
Oh my gosh, Josh.
Yeah.
I have them
What's Mr. Foley's office
I've had
hours?
them every single day for the last 7 weeks, 2 to 2:30
Yeah,
Monday
yeah.
through Thursday, and 9 to 10 on Fridays, but tomorrow is a holiday.
Can anybody tell me what Mr. Foley's office hours is? I mean number.
Go online. All right, everybody else can sign off. I need Mr. Hughes and Mr. Campbell to stay on.
Wait,
All right,
Mr.
Mr.
Gaffney.
Gaffney, we ain't got no work.
Today's the last day.
I have a question,
Wait,
sir.
what are we supposed to do for tonight?
Zion, just leave the chat. There's nothing due tonight.
All right.
We're prepping for geometry. All right,
Thank you, Mr. Gaffney.
all right, we'll see you.
Have a good summer, sir.
Question?
What would my grade be if I didn't go to office hours later today?
For your participation grade, you get a 90. Office hours, you get an extra 10 points, but I wanted you to come to office hours so we could talk about the 6-2 quiz, which was, to put it as mildly as I can, was a disaster.
All right. I also get the extra credit from the office hours and me turning in at 6.
You will get the extra 10 points if you check, anytime you, which that hasn't changed in 7 weeks also. You get 10 points when you check in office hours at least once during the week. That's 10 points on your rep grade. The reason I was asking you to check in is you could look at, oh, he signed off. All right. All right, let me talk about this. Mr. Hughes, this is your 6-2 quiz that you submitted on time, all right?
Okay.
Last week you submitted on May 12th, on time.
Yeah.
Mr. Campbell, after class on Tuesday, I said you didn't submit the 6-2 quiz, and you submitted this 6-2 quiz on Tuesday. It was a week late. These 2 quizzes are identical. Exact same formats, exact same right answers, exact same wrong answers, no names, exact same spacing, exact same punctuation. Tell me how that happened.
It might have been a coincidence.
So that's the explanation. Pure coincidence that every 9 problems, actually 11 problems counting the bonus, were the answers are actually in the exact same positions on the paper too. Tell me how I should best handle this.
A 0.
Pardon?
A 0.
Why do you say that?
I mean, because if you think that it's a coincidence, then you might as well just give it 0. Because if you don't think that we deserve it, then don't give it to us. But if you do, then give it to us. It's your choice. I'm not telling you to do.
Say that again?
If you want us to have a 0, then give us a 0, because then that means that you think that we deserve a 0. But if you think that we don't deserve a 0, then don't give us a 0. It's your choice.
I don't want anybody to have a 0. But
Then I'm
if Mr. Hughes, if you could turn on, whoever's playing the video game, if you can turn that off for just like 20 seconds. If you were sitting in my shoes and this occurred, what would you think?
Give them a 0.
I mean, I got yours, Mr. Hughes, I got yours a week before I got Mr. Campbell's.
Give us a 0. Because if you think that it's a coincidence, then you might as well just give us a 0.
Is it tell me, is it a coincidence?
I mean, I'm using the same word that you did. I'm not trying to like switch up what you said.
But so was there any communication between the 2 of you on this quiz?
as you can tell the time difference, of course not. But if you think that we deserve a 0, then give us a 0.
Mr. Campbell, do you have any comments or thoughts? I mean, you're the one that handed it in a week later, and it looked identical to Mr. Hughes's.
I can definitely see from your position, like how this looks wrong.
What do you suggest I do?
Either you do what you think is right and give us zeros, or like, I don't know, maybe